Hello everyone. Today we will start reviewing Unit 10, 10.1 Static Electricity. Firstly, all of us we heard about the word electricity and maybe we have some information about electricity. But for most of us, it's the first time that we hear static electricity. What do you mean by static electricity is? It's the effect of a stopped electricity. The effect of a stopped electricity. What's that mean? It means in electricity, when we talk or explain electricity, usually we will say the electricity, it moves, for example, from the socket to the bulb, okay, or to the lamp. Here what is happening, the electricity, it's moving. But when you mention static electricity, here it's opposite. Here what do you mean by it? It means the electricity, it has effect when it's stopped, when it's not moving. If we want to take some examples of static electricity, or to give some examples of static electricity, look at this picture. Here, as you can see here, this boy, he's using the balloon, and if you focus here what is happening, the hair, it's sticking to the balloon, or it's getting attracted by the balloon. Okay, here what happened, here it's what do you mean by or what we meant by static electricity. Static electricity, it's a kind of electricity that it generate or it form when you rub two objects together. Describing static electricity, if you want to describe static electricity, we will say it's the electricity that an object will get it when it rubbed with another object. So when you rub a balloon on a cloth, we say the balloon has become charged with static electricity. Okay, so what do we have here? We have two objects. You will rub them with each other, then these objects will gain or will have charge. The charged one, okay, now we call it static electricity. Then attraction and repulsion. Attraction and repulsion. What do you mean by attraction and repulsion? It's like, for example, here when we explain this picture, we said the hair will be attracted by balloon. Okay, so now what's that mean? It means also here in static electricity, we will have some objects will have positive charge while the others will have negative charge. An example of attraction and repulsion, we will take example magnet. Okay, as we know, magnet, it has two poles. If you will have two magnets, you will put these two magnets next to each other. Sometimes they will attract each other, sometimes they will repel each other. So when they will attract, when they will repel, so this it will depend on the charge. But how? Okay, let's solve some questions. What are the rules of attraction and repulsion for magnetic poles? Okay, what do you know about magnetic poles, and what do you know about attraction and repulsion in magnet? Why sometimes the two magnets will attract each other while in the other times they will repel each other? As we know, the magnet, it has north and south pole. Okay, north and south poles. So in another words, it has positive and negative pole. Okay, now when you will have positive next to negative pole, here what will happen? They will attract each other. When you will have positive next to positive or negative next to negative, so they will repel each other. So The rules of attraction and repulsion in magnet, the different charges will attract each other. The same charge will repel each other. Question number 3. How could you test whether a plastic rod that has been given an electric charge will attract or repel a magnet? Okay, here what you need to do. Okay, you need just to put it next to magnet. Okay, and then you will see if it will attract it or will repel it. Describe your method and include a diagram. Okay, so how you will describe it, it's like I just mentioned, how you will make a diagram. Okay, the diagram here will be also as I just mentioned, if they have both of them same charge, they will repel each other. If they have different charge, they will attract each other. 10.2, positive and negative charge. All what I explained, it was about attraction and repulsion. Okay, but how this attraction and repulsion it will happen, or it will be affected by what? It will be affected by the kind of charge. Is it positive or negative charge? People 300 years ago, okay, they didn't know that much about electricity. They didn't have information about electricity. Then by experiments, by doing some tests, so they start uh, having a knowledge about electricity. They start having a better understanding about electricity. So explaining electric forces. The forces, what do you mean by the forces here? It's the charges. Okay, again, you will have two charges, either positive or negative charge. If you look at these two diagrams, here we have one positive and one negative. Here, positive, positive. The difference between them, it's what? The different charges will attract each other. The same charge, it will repel each other. Now, we explained what do you mean by positive and negative charge, but how we will know which one it's positive, which one it's negative, how we can determine it. Okay, so finding the sign of an electric charge. As you can see here, as it's shown in this picture, this tool, okay, this digital meter, okay, they call it column meter. Column meter, okay, you can use a digital meter called a column meter to find out whether the charged object has positive or negative charge. So maybe you'll have a question says which tool they use to find the electric charge. You will say this is column meter. Charging by friction. Firstly, we should know what do you mean by the word friction. Friction, it's when two objects are rubbed with each other. When the surfaces of two objects are in a direct contact, with each other and moving against each other. So, when two objects will be rubbed with each other, what will happen? What will happen? These two objects, they will gain charge. For example, here we have polythene and wool, these two objects. Before you rub these two objects with each other, they will not have any charge. Okay, when they don't have any charge, we call them neutral. So neutral, it's any object that doesn't have a charge. Okay, now when you will rub the polythene rod with the wool, what will happen? The polythene will gain more negative charge, while the wool will, when it will lose the negative charge, so it will be positively charged. So now the friction between polythene and wool, it will gives electric charge for each one of these two objects. Here you need to memorize the charge of polythene and wool. Sometimes in the questions they will give you, they will say polythene. Okay, what is the charge of polythene? Here polythene is always will be charged negatively. Okay, then here also we have another kind of materials. We have acrylic and cotton. So if you will rub these two materials together, what will happen here? It will be opposite. The acrylic will gain positive charge, and the cotton will be negatively charged. So the kind of electric charge, it depends on the material. Each material, it has a specific charge. Okay, some materials always will be negatively charged, others will be always positively charged. So these the charge that appears when two different materials are rubbed together, okay, depend on what? Depend which material are used. Okay, as I said, some materials, they will always be positively charged, others will be always negatively charged. Okay, now questions. Question number 3: what force causes an object to become charged when it is rubbed? Okay, as we just explained, which force? It will be force of friction, because here, as they are saying, they are rubbed, it means rubbing two objects together. When you rub two objects together, that's mean you are moving them on each other, so this we call it what? Force of friction. Okay, now what charge will the cloth have when it has been used to rub an acrylic rod? Okay, we just explained here. So the acrylic is positive, okay, while the clothes, for example, here what do you mean by cotton? You can say cotton or clothes. So the clothes will be negatively charged. 10.3 Electrons on the move. To better understand the static electricity, we should know firstly what do you mean by a charge, and from where this charge it comes. Firstly, all materials or substances are made up of atom. We studied before about atom. We say if we will study the structure of atom, it consists of nucleus, this region, this part, we call it nucleus, and it's surrounded by orbits. These orbits, it contains electrons. Okay, now questions. An atom is usually described as neutral. What does this tell you about the amount of positive and negative charge in an atom? As I explained before, I said substances before you will, or materials before you rub them with each other, they are neutral. What's that mean? It means their atom, it doesn't have any charge. What do you mean by it doesn't have any charge? It means the number of protons, the positively charged, are equal to the number of electrons that are negatively charged. So here what will happen when number of proton it's equal to the number of electrons, so these charges will cancel each other. It's like, for example, if we will do it in math, let's say positive 3 okay, minus 3. Okay, the answer, what will be the answer? So here it will be 0. So what is happening? They are canceling each other. So the nucleus, question number 2. The nucleus of an atom attracts the electrons which orbit around it. This is what stops an atom from falling apart. Explain why the nucleus and electrons attract each other. Okay, there is force of attraction between protons and electrons. Why? Can we explain why? Okay. The explanation for them, or why they attract each other, it's because protons has a positive charge while electron has a negative charge. So here what do we have? We have two different charges. Two different charges, they will always attract each other. Explaining static electricity. Again, static electricity, we said it's the effect of stopped energy or stopped electricity. Here we said materials will be charged if they will be rubbed with other materials. So if there is a friction between two different materials, so some of these materials will be positively charged and the others will be negatively charged. Which one will be positive and which one will be negative? This, it depends on the material that you will use. Question number 3. Use the same ideas to explain why a polythene rod gains a negative charge when it is rubbed with a cloth. Here, the explanation of this. Here, as you can see now, this rod it's positively charged, and here it's negatively charged. What's that mean? What happened? It becomes negatively charged. Why? Because it gains more electrons from here. So here what will happen? The number of electrons will be more than number of protons. So in this case, this material will be negatively charged. This one, when or why it's now positively charged? Because it loses electrons. So now what happened? The number of protons in it, it's more than number of electrons. Protons, which are positively charged, when they will be more than electrons, the negatively charged, so of course this material will be positively charged. Here it's the same thing. It says explain why polythene rod gain a negative charge, or why polythene when you will rub it will be negatively charged. Why it will be negatively charged? Because it gains more electrons. So the atoms of it will have more electrons than protons. Explaining why neutral objects are attracted by charged objects. When you will have a charged balloon, okay, if you will move it next to your hair will be attracted. Okay, but your hair, it doesn't have charge. Okay, if it doesn't have charge, why it's being attracted by balloon? The reason behind this, it's what? Although your hair, it doesn't have charge, but it's made up of atoms, and these atoms, it has electrons in it and protons in it. So your hair, let's say it's neutral, no charge, but if you will move a balloon next from it, let's say balloon is positively charged. Okay, if balloon is positively charged and your hair, it has electrons in the atoms, so what will happen? The balloon will attract your hair. 10.4 Conductors and insulators. Conductors and insulators, what do you mean by it? From the meaning of these words, conductor, It means it conduct. What do you mean by it conduct? It means it let the electricity to pass through it. If you will look at this picture, it shows a wire. This wire, it consists of two parts: metal, plastic. Okay, why do we use this metal and why do we use this plastic? We use this metal to conduct electricity, for example, from socket to lamp or to bulb. Okay, so why do we use metal? Because metal, it has the ability to transfer the electricity. It let the electricity to pass through it. So this kind of material, we call them conductor or conductors. So conductors, it's any material that it let electricity to pass through it. But this wire or this metal, which is copper here, will be covered with plastic. Why? So the plastic will prevent transferring of electricity. It will prevent the contact between this metal with this metal. Okay, this, it has positive charge, this, it has negative charge. These two charges, they should not touch each other inside the wire. So what they do, they cover the metal with a plastic. Plastic, it's what? It's insulator. Okay, so insulators, they do not allow electricity to pass through them. Conductors, they allow electricity to pass through them. Electric current. Electricity makes a lamp light up. Okay. Here we need to understand what you mean by electric current. Okay. Electric current, it's the movement of electric charge. What's that mean? If you look at this diagram, here what do we have? We have a battery cell, okay, wires, switch, and bulb or lamp. Electric current, it's when the charge, it will move through the electric circuit. Two things are needed for there to be in an electric current, or in another meaning, when there will be electric current flowing in this circuit. Firstly, a complete circuit of metal around which the current can flow. What's that mean? If you look at this electric circuit, all of it, it's made up of metals. Okay, these metals, they should be connected with each other to make one closed circle. Okay, then there should be a cell or a battery, a source of energy, a source of electricity. Okay, if let's connect, if we will connect these two ends with each other without battery, what do you think? The bulb will light up? No, of course no. Why? Because there isn't a source of charge, there isn't a source of electric charge. So two important things there should be: one, which is the battery or a source of electric charge, and a circuit, a complete closed circuit. Okay. Question. Study the picture of the circuit. The electric current flows from positive always to negative. Which component does it reach first? The switch or the lamp? Battery will give electric current. This electric current, it moves by this direction, positive. From positive going to negative. So it will reach which circuit component firstly? The switch or the lamp or bulb? So the answer, of course, it's the switch, because it moves by this direction. It goes firstly to the switch, and then if the switch is closed, then it will pass to the lamp. Circuit symbols. If you will look at these two diagrams, this one and this one, both of them, they represent the same thing. Both of them, they represent electric circuit. But here, instead of using pictures of the electric circuit components, what do we use here? We use symbols. So cell, battery, instead of drawing a battery, we can just use this symbol. Instead of drawing a switch, we can use this symbol. Instead of drawing a lamp, we can use this symbol. Instead of wires, we can use these lines. So, circuit symbols. Scientists and engineers draw circuit diagrams to show how different components are connected together in an electric circuit. They use what? They use circuit symbols. Okay. Here are the three main component of electric circuit. We will study more components in the next pages. Study the circuit diagram. Questions. Draw the circuit symbols for a cell, switch, and lamp. Okay. Here it's the answer. Cell, switch, lamp. Okay. One more thing about cell. As you can see here, we have these two lines. One is short, one is tall. Okay. Why do we have two different lines? It's one end, it represents the negative charge. This one, the small one, it represents the negative charge, and the tall one, it represents the positive charge. Question number 3. Which part of the symbol for a cell represents the positive end, and the long line or the short line? The answer I just explained here. Okay, the long one, it represents positive. The short one, it represents negative charge. 10.5 Electric current in a circuit. 10.5, it's about how or when we will know there is electric current in an electric circuit. Let's take this example. This as the simplest example that shows if there is electric current in an electric circuit. Firstly, if the lamp lights up, there is a current. In this diagram or in this electric circuit, when the lamp will light up, that means there is electric current. Then how we will know how much is the electric current? A brighter lamp shows a bigger current. What's that mean? As much as the light will be brighter, that's mean the current here, it is a bigger. Then, how we will measure this electric current? To measure the electric current, we have a specific tool. We call it a meter. So, we can measure the electric current in a circuit using an instrument called a meter, an ammeter. Okay, it's the symbol that we use to draw the symbol that we use it when we draw electric circuit. Then this electric current, it has a unit to measure it, which is AMP, ampere. Okay, so don't mix between the tool that we use it to measure the electric current and the unit that we use it for measuring electric current. The tool or the instrument, we call it a meter. The unit, we call it AMP or ampere. So as you can see here what do we have? We have the cell, switch, bulbs, and a meter. So here we will measure how much electric current it's flowing in this electric circuit. Current in a series circuit. Series circuit, if you remember, we talked about the two types of electric circuit. The first type we call it series. The other one we call it parallel electric circuit. The difference between series circuit and parallel circuit. Here in series circuit, like this, okay, uh, in a circuit like this, we mean by it, in a series circuit, the components are connected end to end. Okay, this is the first component. The second component, how they are connected with each other, end to end. Okay, their ends are connected with each other. One important thing, the current flows through the component one after another. The current is the same all the way around a series circuit. For example, if you will be asked how much is the current here, let's say here it was 5. How much it's here? 5, 5, 5, and so on. So I made this table for you. Okay, here we have the two types of electric circuit, series and parallel. Okay, current, electric current, how is the electric current in series and also in parallel? In current, it's what? It's the same. What do you mean by it's the same? It's the same around all the electric current cell. Questions. Now we will talk about this, and this part we will talk about it then. Does the electric current get used up as it goes around an electric circuit? No. Okay, it says if there is electric current and it's stopped, it's not moving, just stopped in the electric circuit. Will it be used up? The answer will be no. In a series circuit, an ammeter shows that the current leaving the positive end of a cell is 0.5 ampere. What current flows into the negative end of the cell? It says, let's say here, you don't have these two lamps, just positive and negative end. The electric current will pass from positive to the negative as we mentioned before. Now, if 0.5 ampere are leaving the positive end, it will goes to the through wires and then to the negative end. If here it's 0.5, how much will it be here? The answer, because the electric circuit, it's what kind of electric circuit? It's series electric circuit, so the electric current will be the same. This is what they mean by the electric current in a series circuit. It's the same. 10.6, understanding electric current. Here we should understand what do you mean by electric current, or when we say electric current, it's the charge passing in electric circuit. What do you mean by it? As we mentioned before when we talked about conductors, we said conductors are substances that it let electricity to pass through it. What's that mean? Here, this is a copper, which is metal. It let electricity pass through it. But what do you mean by, or how the electricity it will pass through it? This metal or this substance, this material, it's made up of atoms. These atoms, it has electrons. Okay, so as you can see here, when the electricity it will pass through it, what's that mean? It means the electrons are moving. Okay, why metals conduct electricity? Metals are useful materials because they contain a lot of electrons which can move about inside the metal. The electrons are not tightly attached to their atoms. That is what makes metal different from other materials. Okay, so why metals are good conductors? Because their electrons are not tightly attached to the atoms, so they are free, or they can move freely. So charge is moving through the metal. This is what we call an electric current. Okay, when the charges are moving in the metal or through the metal, this, what do you mean by electric current? How a cell makes a current flow. Okay, here firstly we should remember the definition of electric current. It's the definition for electric current. We will say it's the passing of electric charge. Okay, here we didn't mention what kind of charge. It's just the movement or transferring of electric charge. We didn't mention if it's positive or negative, so you will not confuse when I will explain this part. Think about a cell. One end is positive and the other one is negative. The positive one here, this positive one, because maybe someone will say, but Mr. When you explained, you said the electric current, it moves from positive to negative, and here it's showing opposite. Okay, electric current, it's the movement of charges. Okay, we didn't now mention which one, positive or negative. Now, as you can see here, the positive end, it will attract electrons that have negative charge. So now this arrows, it shows what? It shows the electrons. The electrons are moving from negative to be positive, positive, because they are attracted by the positive end. Okay, then, so when a circuit is complete, the electrons in the metal of the circuit start moving around it. They are pushed from negative end of the cell and attracted toward the positive end. Now, the electrons will move from negative to positive. Okay, but when we say it, the electric current, it moves from positive to negative. What did we mean by it? Electrons moves in the opposite direction of the conventional current. Okay, now what is conventional current? Conventional current, it's the flow of positive charge and is directed from positive terminal of the battery to the negative terminal. Now, how cell makes current flow? Again, the electrons will be moved from the negative end to the positive. Okay, at the same time, the positive or the conventional current, it's what? It's the movement of it's the flow of positive charges from positive to the negative end. Lighting a lamp, current and energy. Any lamp, to light up, it needs what? It needs energy. So it needs energy. So this energy, it will move, as you can see here. It's what? It's moving from positive to the negative. Okay. Another component in a cell, we call it buzzer. Okay. This is the buzzer. The buzzer, this buzzer, the function of it, it's what? When electric current, it passes through it, it will start making sound, or giving it will start buzzing. Okay, makes a sound. The function of it, it's to make sure that electric current is passing through the electric circuit. 10.7 Changing circuits. Number 1. What do you mean by changing circuit? It means some changes that we will make it to the electric circuit in order to change other things. How? For example, if you look at this X-ray, here it's you have a torch, a picture of torch that it took by using X-ray. A torch like this needs two cells to give enough current to light the lamp brightly. Okay, what do you think? What will happen? Here the question says, what would you observe if the torch had only one cell? Explain your answer. Of course, if this torch has one battery, one cell, that means this torch will, the light of it, the lamp of it, it will not light up. Why? Because there won't be, there will not be enough current to make the light, to make the lamp light up. So, what's that mean? Voltage. A new word. Voltage, it means it's what makes electric charge move. In another words, if we want to give another definition for it, we will say it's how strong the electric current is. Or you can say its definition for it, it's the strength of electric current. Now, we know that electric current, its charges are moving in the circuit. But how strong this how strong these charges are moving, this it's what we mean by voltage. So voltage, cells are usually labeled with their voltage. How we on this cells, it's written, for example, it's 1.5 V or volt, or others they are 9 volt. We have, for example, car batteries are written on them 12 volts. Okay, so how we will know how much volt it is? So we will use a tool or instrument, we call it voltmeter. So voltmeter is used, it's a tool that used to measure the voltage. How to draw it on electric circuit diagram? We will draw it in this way. Circle, inside it there is the letter V. Okay. Again, voltmeter, a tool that it's used to measure the voltage. Okay. We represent it by V. Then what will happen if you will have more cells? This battery, now it has this torch, it has two batteries. Okay, what will happen if we will give it 3 batteries or 4 or 5? If we will add more cells, what will happen? If 2 or more cells are connected together in series, okay, focus on the word in series, the voltage add up. Okay, now if you have electric circuit, it has one battery in it, let's say for like this one, now it's 1 point V. But if you will add another battery to it and you will put it in a series, you will connect it in series way, so that's mean end to end. So how much will be the voltage? 3. If we will add another battery, 4.5. Okay, so what is happening here, more cells, more voltage. If we will go back to the table, to this table, okay, voltage in a series electric circuit, it's what? It's sum of all individual volts. What's that mean? It's the sum you will add. How you will get the sum? By adding. So what is the total voltage? It's the sum of all voltage. Here, as you can see, it's 0 volt. Why? As you can see here, how they are connected to each other, negative with negative. It should not be in this way, because negative with negative, there won't be any movement for the charges. It should be connected with positive, negative, and so on. Draw the circuit symbol for a voltmeter. This is the answer. Okay, a circle and the letter V inside it. Question number 3. If the torch in the photograph above had two cells, each labeled 1.2 volt, what would the total voltage be? Because these batteries are connected in a series, which is end to end. Now, in a series, what we will do, you will add all the voltage. So if each one is 1.2, so how much will be the total? It will be 2.4. Now, more volts, it goes more amperes. What's that mean? If you have electric circuit and the electric current is flowing in it, let's say this electric current, it's, for example, let's say here, okay, you will have 10 charges are passing through this electric circuit in 1 second. Okay, if you will add more volt, what's that mean? It will be stronger. Okay, when it will be stronger, what's that mean? The charges will move faster. So now, for example, what will happen? 20 charges will pass the electric circuit, or 20 charges will pass in 1 second. So now what happened? You add volts. When you will add volts, it means also the amperes will increase. (10.8) Changing circuits 2. In 10.7, a change that we did to the circuit, it was adding more energy to it by adding more cells. In 10.8, we will see what will happen here if you will keep the same number of batteries or cells, but we will add what here? We will add another components. We will add, for example, another bulb. Predict what will happen to the electric circuit. Any lamp or any bulb to light up, it needs energy. So in this case, when you will put two lamps in series, which means end to end. So if we will understand how the electrons will move in electric circuit, so we can understand or we can figure out what will happen to the light here. This light or this bulb to light up, it needs electrons or it needs charge to pass through it. But it will pass through it and then will goes back again to the cell. But here, if we will add another bulb, so what will happen? Now, this bulb to light up also will need charge, will need energy. So now, here, the battery, it has to push the electrons or to push the charge hardly. So what will happen now? The charge or the energy, firstly, it was all of it going to only one bulb, but now it's two bulbs. So in this case, what will happen? Okay, this energy will be distributed into two lights, two bulbs. So both of them, they will be dim, not bright. Electrical resistance. Electrical resistance, we say that a lamp has a resistance. What's that mean? When you have a bulb or a lamp, to light up, the energy it should pass through it. So what is happening here, this light is resisting the movement of the charge. Okay, each light, each bulb, it has a specific resistance. So let's say you have a bulb that it needs 5 volts to light up, and your source of energy it's 10. So 10 volts. So in this case, what do you think? What will happen? The bulb, it can handle up to 5 volts, but the source it will give 10 for. So in this case, what is happening? The bulb will receive more than what it can handle. In this case, the bulb will explode, or it will damage it. Now, how to solve this problem? By using specific components, we call them resistor. So what is this resistor, or what's the function of it? Resistor is used to make current smaller in the circuit. So we have different types of resistors. Now the main idea of it is what? It will make the current smaller. So in this way we can save the bulb. For example, your charger, your phone charger, okay, the voltage in electricity that we use at home, it's 220 volts, but our phones, to charge it, you need just like 2 or 3 volts. Okay, so in this case, how to solve this problem? The charger, inside it has a resistor. This resistor, the function of it's what? It will reduce the 220 volts into for example 2 or 3 volts. This is the symbol that we use it to represent the resistor while drawing the electric circuit. Here we have another kind of resistor, we call it variable resistor. Here you can adjust this manually, so you can change the amount of electric current in it. Buzzer, okay, also here it's the symbol of buzzer, okay, symbol of buzzer, symbol of variable resistor. Losing energy. How energy will be lost in the electric circuit? When two components are connected in series. Okay, what do you mean by series? Which is end to end. It is harder for the current to flow. There is more resistance, and so the current is smaller. Again, as this example, okay, why the electric current will be smaller in this electric circuit? Because there are 2 bulbs. If we will add another bulb, also as much as we will keep adding more bulbs, the current will be smaller. Why? Because the current is being resistant by the bulbs. Here, look at this question. Explain why the current in the circuit would be bigger if there was only one resistor in the circuit. Imagine you have electric circuit and you have many resistors in it. For example, you have 2 electric circuit. One of them, it has 1 resistor, and the other one, it has 2 resistors in it. Explain why current in the circuit would be bigger if there was only 1 resistor. Okay, the answer, because the electrons will move easier. Okay, as much as the resistance it's less, that's mean the electric current, okay, will flow faster and it will be bigger. 10.9 components in parallel. In the previous uh, topics, okay, we were talking about electric circuit in a series or series electric circuit. In series electric circuit, we say all the components are attached or connected end to end. And when electric charge or the electric current it passes through the bulbs, okay, as much as we will have more bulbs, then it will be dimmer. What's that mean? Or how to solve this problem? You can connect the bulbs in another way, which is side by side. Okay, here what it's happening, they are connected side by side. So in this way, this we call it parallel electric circuit. This parallel electric circuit, it solves the problem that adding more bulbs will be dimmer. Okay, so in a parallel circuit, as much as you will add more bulbs, all of them they will be the same. They will be, their brightness will be the same. But one more thing here will happen, which is the electric current here will be bigger. If we want to explain it, current in parallel circuit. The circuit diagram shows the same circuit as before, okay, which it's like this one, cell, bulb, bulb, cell, bulb, bulb. The difference is what? But drawn slightly differently to make it easier to understand how the electric current will flow. Now, let's see how the electric current will flow through it. The current flows from the positive end. Now, the start point is here. From the positive point. It will move from positive point or positive end of cell. It will move until it will reach the point A. When it will reach point A, it divides. The current will be divided. Some of the electric current will go to the bulb, to the first bulb. Again, some of the electric current will go to the bulb and the rest will keep moving. Okay, when it reaches point A, it divides. Half of the current flows through one lamp and the half flows through the other. Okay, current, it comes from positive. When it reaches point A, half of it will go to this lamp. The other half will go to the next one. Okay, then and here will match again. When the two currents reach point B, they join together again. Then they flow back to the cell. You need to focus more on the number of arrows here. Here we have two arrows. One, it goes here. It means half of the electric current, and the other half, it comes here. Then again, at point B, they will join each other again. Okay, this means that when there are two identical lamps in parallel, there is twice as much current as when there is only one lamp. Okay, it means now here the brightness of these two lamps will be the same, but as much as you will add more lamps, more bulbs, okay, you will need more electric current. It will take more electric current. Okay, so in this way, this shows that it is easier for the current to flow when two components are connected in parallel. The current will flow easier when they are connected in parallel. Why? Because there is less resistance and so the current is bigger. That was everything for Unit 10. Your task is to solve the end of unit questions, and then when you will watch the video again, write a comment so I can make sure you got or you received the video, you got everything from the video. If you still have any questions, any concerns, please don't hesitate to contact me. Thank you and have a good day.